So the first concept that we learned in class was momentum. This was our starting point. And so our definition of momentum was basically momentum, which is a vector, is equal to the mass times the velocity, which is a vector. Remember, scalar times a vector is another vector. And our velocity is just the position vector. So this r vector is a position vector divided by the change in time, right? So this is just derivative of that position vector with respect to time. And so this was basically considering point particle, and it's moving at some, it has some mass, some velocity, so it has some momentum. But what if we have some, like we want to know what is the momentum of a person? And so what we did when we were talking about that is basically said, okay, well, let's say that every atom in the person, like take every atom and say this atom has P1, this atom has P2, this atom has P3. And what we figured out is basically if you add up the momentum of all the different atoms in the person, what you can get is you can basically say that all of those added together is equal to the total mass of the person times the velocity of their center of mass. So basically, you just find their center of mass and figure out how it's changing with respect to time, the position of the center of mass changing with respect to time, and that'll give you the total momentum. So in order to describe the velocity of the center of mass, we actually had to define over here what the position of the center of mass is. So here's our expression for the position of the center of mass, and we use this, for example, for an isolated system. We know that r cm doesn't change, and that was, we had, for example, we had this problem with the Earth, and there was some person on it, and they jumped up, and then the Earth, right, so the Earth would move down, and the person, their center of mass would move up, and based on how much the person moved, we could figure out how much the Earth moved, just because we knew the center of mass stayed the same. So that's one way we used it, but the real reason we made this definition was because we could then define our VCM, which was equal to dr cm dt, and then this follows the relationship that P total is equal to M total times dr cm dt. And so basically the point of all of this on this, all of this stuff here is just so that we can, treat an extended object as a point particle at the center of mass of that extended object.